All right, so this section is on miscellaneous equations, and this is probably the longest and probably the most difficult section in a college algebra class, I think. One of them anyway. It's a lot of different types of equations to solve, all right, and it's a long section. So let's go ahead and get started. So let's just start off. Let's solve. So we're going to start off by solving some polynomials. And the way we're going to do it is we're going to factor them. So you've got to go back to what you learned in factoring and apply that. So here we've got an equation. We've got 4 terms. So if you remember, when you have 4 terms, you want to split it down the middle and try factor by grouping. Okay, so if I look at the first part, I can factor out an x squared, and that'll leave me with x plus 3. I just factored out a common factor of x squared. And then if I look here, well, there's nothing to factor out. The greatest common factor is 1. But what I'm going to do here is I'm going to go ahead and write a 1 down, like I'm factoring it out. And that just leaves me with x plus 3. And the reason that I did that is because now it's easier for me to see my common factors. And so when I factor out an x plus 3, if I factor it out of this first term, you can see I'm left with just the x squared. And if I factor it out of the second part right here, you can see I'm left with the 1. And that equals 0. And then we set each one equal to 0. And so this one's easy to solve. That's just what? X equal negative 3. What did we do? We subtracted 3 to both sides. All right, so there's one solution. And then what about this one? Well, if you remember back when you solved quadratic equations, we've got something squared here. We've got this x squared and a constant. So we can solve for the x squared, just subtract 1 to both sides. And then I can use that square root property. So x is equal to the plus or minus the square root of negative 1. And so x is equal to plus or minus the square root of negative 1 is I. And there's my, I get 3 solutions. So we could actually write them out: negative 3, negative I, and I. Okay. And if you wanted to, you could write it negative 3 plus or minus I. You know, any of them's fine. All right, so let's take a look at the next problem. So remember, when you factor, you want to factor out the greatest common factor first if you can. So we can see here that the greatest common factor is 2x. And if we factor out a 2x, that's going to leave us with 15x squared plus 8x minus 12, and that equals 0. All right. And then we need to see if we can factor this trinomial here. So that's 2x times, and let's see, that will factor into what? 3x minus 2 and 5x plus 6. See, if I fold this back out, I end up with this. This just goes back to knowing how to factor. And remember, in college algebra class, it's assumed you know how to factor. All right. If you have trouble factoring, you need to go back and review it. And then we just set each one equal to 0. All right, so here I'll divide both sides by 2. I get x equals 0. Here we'll add 2, so I get 3x equals 2. Divide both sides by 3. I get x equal 2/3. or, and here I'll subtract 6, and then divide both sides by -5, and so x equals -6/5. Okay, so our solution, we get -6/5, 0, and 2/3. All right, and I just put them in order from smallest to largest. That's all I did. Okay. All right, so what about this one? All right, so once again, I have 4 terms, right? I've got 4 terms. So let's split it down the middle. And out of the first part, I can factor out an x squared, and that leaves me with x minus 2. And then out of this part, I can factor out a 5, and that leaves me with x minus 2. If I factor the 5 out of this part right here, and that equals 0. And then you can see we've got a common factor of x minus 2. So x minus 2, and then I'm left with x squared plus 5 equals 0. And so I get x minus 2 equals 0, or x squared plus 5 equals 0. And so I'll add 2 to both sides, so x equals 2, or, and then here I can use the square root property again. So x squared equals -5, and so x is equal to plus or minus, and then the square root of -5, that would give us I square root of 5. So I would get 2 plus or minus I square root of 5. And there's your answer. See, they're not too bad. Okay, it's not too bad. You have the tools to do all of this. You've just got to be able to bring them all together. Okay. All right, so let's look at this next example. So first, let's get everything to one side. All right. And so I'm going to subtract 16x squared to both sides. So that's going to leave me with 2x to the 5th minus 16x squared equals 0. And then let's factor out the greatest common factor. So that's going to be 2x squared. And I'll be left with x cubed minus 8. And that equals 0. So let's set them. Well, we can set them equal to 0, but what do you think we might need to do first? Probably factor this, because it'll still factor, won't we? So we've got 2x squared times, now remember, x cubed minus 8 is x cubed minus 2 cubed, and that's what we're factoring. So if you remember back when you were factoring difference of 2 cubes or sum of 2 cubes, you just drop the cubes, and that would be x minus 2. And then you square the first term, change the sign, multiply the 2. This is always positive here, and then square the last term, and that equals 0. Now, let's go ahead and set each term equal to 0. So I've got 2x squared equals 0, or x minus 2 equals 0, or x squared plus 2x plus 4 equals 0. Now, the first two here, that's easy to solve. So I'm going to divide both sides by 2. So x squared equals 0, x equals 0. You don't put plus or minus 0. Okay. And then this one, I'll add 2 to both sides, so I get x equal 2. Now, this one, we need to solve this one, but it doesn't factor. So if you remember, you have 2 options. You can either complete the square or you can do the quadratic formula. All right. I'm going to go ahead and just complete the square on it. Okay. And because most students know how to do the quadratic formula, so I'm going to complete the square because this middle term's even. I'm not going to have to deal with fractions. So let's complete the square. So I get x squared plus 2x, leave that little space, and I'm going to subtract 4 to both sides, minus 4. And so now I half the 2, that's 1, and then I square the 1, and that's 1. So I'm going to add 1 to both sides. And so remember, this is what x plus 1 squared equals -3. So x so x plus 1 is equal to plus or minus I square root of 3. I don't know what happened. I don't know if you saw that, but something happened. It wasn't writing good on the screen, technical difficulty, so it's working again. All right, and then I'm going to subtract 1 to both sides, so x equals -1 plus or minus I square root of 3. And then we write our answers. That's 0, 2, and then -1 plus or minus I square root of 3. And there's my answer. All right. All right, so that's solving equations with polynomials. Okay, you got polynomials, we're factoring them, and all that good stuff. All right, so now let's come down here to solving equations with radicals. Okay, we've got square root. So whenever you're solving an equation with a square root, you want to isolate the square root. You want to get it on one side by itself. And you can see in this problem, the square root is already on one side by itself. So now all we do is square both sides. And so this is going to be x equals x squared minus 4x plus 4. Now remember, this x minus 2 squared, don't write that down as x squared plus 4. Okay, students do that all the time. That is not correct. Okay, remember, this is x minus 2 times x minus 2, and you FOIL it out, and that gives you the x squared minus 4x plus 4. All right, so now I have a quadratic equation to solve. So I'm going to subtract x to both sides, get everything to one side. So that's going to leave me with x squared minus 5x plus 4. And look, I know this would be 0 over here, but we can put this equals 0. Remember, there's a property that says a equals b is the same thing as b equals a. It doesn't matter what side of the equal sign you put it on. All right. Well, and now let's factor. And so we get x minus 4, x minus 1. And so x minus 4 equals 0, or x minus 1 equals 0. Add 4 to both sides, x equal 4. Add 1 to both sides, x equal 1. So that's the two solutions I get. But we're not done. Whenever you square both sides, actually whenever you raise both sides to an even number, to the second power, to the fourth power, sixth power, eighth power, 10th power, whatever, if you raise both sides to an even number, you have to check your solutions. In other words, you've got to take each solution and plug it back into the original equation. Okay? If you raise both sides to the third power or fifth power or seventh power, if you raise both sides to an odd number, you don't have to check your solution. You can, but you don't have to. So if you're ever in doubt when you're solving an equation, if you're ever in doubt, do I need to check my solution or not? Just check it. You can't go wrong checking it. Okay? So let's come over here and check. So let's check our solution. So let's check x equal 4. So let's plug the 4 in. So square root of 4 equals 4 minus 2. Now we're not squaring it. I'm plugging it back into the original. And I need to know, do those equal each other? Well, the square root of 4 is 2. 4 minus 2 is 2. That checks. So x equal 4 is a solution. Now, let's check x equal 1. So let's plug that in. So I get square root of 1. I'm just plugging the 1 in for x equals 1 minus 2. And so I get 1 equals negative 1. That does not check. So x equal 1 is not one of my solutions. Okay. All right, let's look at the next one. All right, so remember, whenever we're solving these things, you've got to isolate the radical. You got to isolate your radical. Well, in this problem, we've got two radicals. So we isolate one of them. So I'm going to go ahead and just add square root of x to both sides. So that's going to give me square root of 2x plus 1 equals square root of x plus 1. And then I'm going to square both sides. All right. And so when I square this, that's going to give me 2x plus 1 equals. Now for this one, I know up here in this previous problem, I just did this in my head. But since we have a radical there, let's go ahead and write it all out. So that's square root of x plus 1 times square root of x plus 1. And then let's FOIL it out. Okay, let's not do it in our head. It might confuse you if we do. So that's going to be 2x plus 1 equals, so I multiply the first, square root of x times square root of x is x. Square root of x times 1 is square root of x. 1 times square root of x is square root of x. And 1 times 1 is 1. And then what I'm going to do is I'm going to combine these like terms. So x plus 2 square root of x plus 1. All right. All right, so we're good here. Hope everybody's with me so far. I've got another radical, don't I? But I did get rid of one of them. I only got one now. So let's isolate that radical. So to isolate that radical, I'm going to subtract x to both sides, and I'm going to subtract 1 to both sides. So that's going to give me x equal 2 square root of x. The 1's go out, and 2x minus x is x. Now, if you remember, I said isolate the radical. Get the radical by itself. So let's just come over here to the side and let me show you something. X equal 2 square root of x. Now, if I isolate that, I'm going to divide both sides by 2. I get x over 2 equals square root of x. And then if I square both sides, I'm going to get x squared over 4 equals x. And that's fine. There's nothing wrong with that. Okay? Nothing wrong with that. But what's the problem? We have fractions. And if you've watched my previous videos, you'll know that one of the things I've talked about a lot in the videos is we don't like working with fractions. We get rid of them if we can. Okay? Well, you see this 2 here? Because that 2 is multiplied to the square root of x, we can just go ahead and square both sides like this. We don't have to get rid of that 2. Now, if that was 2 plus the square root of x, then no, you couldn't do that. If you had that, then you would have to subtract 2 to both sides. But because it's multiplied, we can go ahead and square both sides. All right, and what this does, this avoids us having the fractions in the equation. Okay, but you know, if you want to do this over here, what I'm erasing, that's fine. You can do that. You just have to work with fractions. All right, so this is going to be x squared equals, and then remember, be careful when you square this, you got to square each one. So 2 squared is 4, square root of x squared is x. And see now, you see how much easier that is, how much better that looks? No fractions. Okay? And so this, I'm going to subtract 4x to both sides. And so that's going to give me x squared minus 4x equals 0. All right. And then I'm going to factor out an x. And so I get x equals 0 or x minus 4 equals 0. And so now I add 4 to both sides. Here I get x equal 4. And so these are my two solutions. And let me go on ahead and come up here. So I got x equals 0 or x equal 4. But remember, I squared both sides. So that means I have to check my solutions. So let's check. So let's check the x equals 0 first. So remember, we have to take it and plug it back into the original. So that's going to give me the square root of 2 times 0 plus 1 minus the square root of 0 equals 1. I need to know, is that a true statement? Well, let's see. 2 times 0 is 0. 0 plus 1 is 1. The square root of 1 is 1 minus the square root of 0, which is 0. 1 minus 0 is 1, which equals 1. That checks. And so x equals 0 is a solution. Now let's check x equal 4. And so that's going to be square root 2 times 4 plus 1 minus square root of 4. And we need to know, does that equal 1? Well, this is what? 8, right? Plus 1 is 9. Square root of 9 is 3. Square root of 4 is 2. 3 minus 2 is 1 equals 1. Well, that one checks also. And so this is our solution. So our solution in this case is both of them. They both worked. Okay? All right. So, but you know, that's why you have to check them. It's not going to always be one works and one doesn't. Okay? You could have one works, one doesn't. You can have both of them work, or you can have none of them work. Okay? If none of them work, then it's just no solution. All right. All right, so here's another one. Let's look at this. And you know, if you want to, pause the video and see if you can work this one on your own. This is similar to the one we just worked. Okay. All right, so let's isolate the radical. So I'm going to add square root of x minus 2 to both sides. And so that's going to give me square root 3x minus 2 minus, no, not minus, equals square root of x minus 2 plus 2. And then we're going to do what? We're going to square both sides. And so that's going to leave me with 3x minus 2 equals, and then let's go ahead and write this out, FOIL it out. Let's not try to FOIL this one in our head. If it's one like the first problem we worked, then yeah, you know, something like this or something like this, squared. Yeah, FOIL that in your head if you can. If you can't, write it out like I did here and FOIL it out if you need to. There's nothing wrong with that. All right, so this is 3x minus 2 equals, so I'll multiply the first, that's x minus 2. The outside, 2 square root of x minus 2. The inside, 2 square root of x minus 2, and then the last. And then I'm going to do what? Combine like terms. So that's 3x minus 2 equals x plus 4 square root of x minus 2 plus 6. Nope. I almost messed it up, didn't I? I was looking at that plus 2. So negative 2 plus 4 is 2. All right. Now, let's isolate the radical. So I'm going to subtract x, and I'm going to subtract 2. And so that's going to leave me with 2x minus 4 equals 4 square root of x minus 2. All right. So we're isolating the radical, right? And this, what I mentioned in the previous problem, this is a good example of not wanting to divide everything by 4. because we would have what, 1/2 x minus 1 on this side if we divided both sides by 4. And then can you imagine when we square both sides, pulling that out? Okay, that's what I'm talking about. Avoid the fractions if you can. Right? So now look, if this number divides into both of these evenly and you don't end up with fractions, then divide both sides by this number. But if you're going to divide both sides by this number and end up with fractions, then just don't worry about it, and then just go ahead and square both sides. All right, so this is going to be 4x squared minus 16x plus 16 equals, and then I got to square both of them, so that's going to be what? 16, 4 squared is 16, and then square root of x minus 2 squared is x minus 2. And then let's distribute the 16, so 4x squared minus 16x plus 16 equals 16x minus, and that's 32. All right? And so now I'm going to subtract 16x to both sides, and I'm going to add 32 to both sides. And so that's 4x squared minus 32x plus, what is that, 48 equals 0. That's some big numbers there to factor, right? But we've got to use our head. We've got to go back to when we learned how to factor. Factor out the greatest common factor. Or you could divide everything because we have an equal sign. What's the greatest common factor? 4. So look, just come up here, divide everything by 4. And so that's x squared minus 8x plus, what is that, 12 equals 0. And so this factors, that's going to be x minus 6 minus 2. So x minus 6 equals 0, or x minus 2 equals 0. So x equals 6 or x equal 2. All right, so let's write that up here. X equals 6 or x equal 2. And so we have to check. All right, so check. So I'm going to check x equals 6. So let's just go ahead. I'm not going to go through and show the work. I've shown it on the previous two. So what is that? That's 18 minus 2. Okay. So look, you could just come over here and kind of do it in your head if you wanted to. But if you're taking a test, your teacher might want you to show the work. So, you know, show the work if your teacher wants you to. And yes, if you're in my class, I want you to show the work. All right. So plug the 6 in. That's 18 minus 2 is 16. Square root of 16 is 4. 6 minus 2 is 4. Square root of 4 is 2. And that equals that 2. And so 2 equals 2. That checks. So the 6 is one of our solutions. And then we're going to plug the x equal 2 in. We'll check that. That's what? That's 6 minus 2 is 4. Square root of 4 is 2. And then plug this 2 in. 2 minus 2 is 0. So that's minus 0. Does that equal 2? 2 equals 2. That one checks also. And so we get both of them work. Okay? All right. And no, just because you square both sides twice doesn't mean both of them's going to work. I know that happened on the two problems we worked, but that's not going to always be the case. Make sure you plug it in and check them. All right, now, what about solving x to the m over n equals k? We have a rational exponent, don't we? You see that? So here's some guidelines to go by. Raise each side to the n over m. Okay. If m is even and k positive, then x equal plus or minus k to the n over m. And if m is odd, then x equals k to the n over m. All right. So, yeah, I mean, you need to know this right here, but let's just go through it, and as we work the problem, I'm going to explain how these apply. All right. So when we're solving this, if you notice in all the problems that we've worked, we've got an answer here and here. Do you notice the exponent is a 1, right? That's the exponent. When we solve an equation, we get x equals something, right? X equals some number, and it's x to the first power, okay? So when we're solving this, well, that's what we want. We need an x to the first power. Well, how do we do that? Let me move this over some. Equals 625. All right. So how do we go about doing this? Well, remember when you had a to the m raised to the n, that's a to the m times n, you multiply the exponents. So if we raise both sides to something, what can I multiply to 4/3 to get 1? Well, you can multiply the reciprocal, right? 4/3 times 3/4 is 1. And that's what we're doing. This is raised to the 3/4 power. Okay? And look, that's what they're talking about right here. See, if you have x to the m over n, they're telling you to raise each side to the n over m, because when you multiply these, the m's cancel out, the n's cancel out, and you're left with x to the first power. And that's why you're doing that. So, you know, in all honesty, you can actually do that in your head. So you could just say x equals 625 raised to the 3/4, raised to the reciprocal of that exponent there. All right, that's all that's happening when you're doing this. Okay. Now, they also said if m is even, so in other words, your exponent here, if the numerator is an even, number, then you've got to put the plus or minus out in front. All right, so for right now, just bear with me on the plus or minus. And I'm going to explain to you as we're working this problem, I'm going to explain to you where the plus or minus comes from so it'll make more sense. All right, so now we need to evaluate this 625. All right, so to evaluate this, then what we got to do is convert it to radicals. Remember going from exponential to radical form and radical form to exponential form? Remember, there's a property that says a to the m over n is equal to the nth root of a to the m, and also a to the m over n is equal to the nth root of a to the m. Either one. But if you watch the lesson on this, the rational exponent lesson in the playlist, this one right here is the easiest one to use most of the time. This makes it easier to evaluate. Okay, so let's go ahead and convert this to radical form. So that's going to be x is equal to plus or minus, and that's going to be the 4th root of 625 and all of that cubed. All right, just remember the denominator, that's the index of your radical, and the numerator is the exponent out here. All right, now let's look at this. If you remember when you had something like x squared equals 9, then x is equal to plus or minus 3. We did that in several problems at the beginning of this video. We used that square root property. Well, there's something else that's called an nth root property. Okay, so if you've got x to the n equals some number k, And if this exponent here is an even number, then x is equal to plus or minus the nth root of k. All right? It goes with that square root property. Okay? If the exponent is an even number. Okay? All right. So if you look at this, we're taking the nth root of both sides, right? The nth root of both sides. N is even. Well, do you see this? This is the fourth root. It's like we were taking the fourth root of both sides, and so we've got to put the plus or minus. Okay? If you remember, when you convert from exponential to radical form, remember this denominator here is the index of your radical. So this denominator, okay, is the index of your radical. So remember, if the index is even, you've got the plus or minus in front. Okay? If it's odd, just like this says up here, you don't have to worry about plus or minus. Okay? All right, so I hope that made sense. If it didn't, just, I don't know, maybe rewatch this part of the video and see if it clears it up, or find another video, that might explain it, better than I do for you to understand. But just remember, if this denominator, when you're converting it, when you're solving these problems and you're converting this to radical form, and that denominator is an even number, you're going to have plus or minus. Or, just remember, like this said, if m is even, what's m? M is that numerator right there. See, there's your m. That's the numerator. All right. So now we get x is equal to plus or minus, and then the fourth root of 625 is 5, and that's cubed. And so x is equal to plus or minus 125. And there's your answer. You get two solutions on that problem. Okay? All right, let's look at the next one. So remember, what we're doing is we're raising both sides to the reciprocal of this number. And remember, when I raise this side over here to the reciprocal of this number, I just get this raised to the first power, right? Okay, just like over here. And so that's just y minus 2 to the first power is just y minus 2. And that equals 32 to the negative 2/5. All right. So now let's go ahead and solve this, but I need to make my exponent positive. That's over 1. And so I'm going to move it across the fraction bar. Remember, when you move something across the fraction bar, it changes the sign of the exponent. So I get y minus 2 equals 1 over 32 to the 2/5. And so now let's just simplify this. This is going to be y minus 2 equals 1 over the 5th root of 32 squared. Okay. Now you can see here, this is not plus or minus, right? Because look, you see your index, the index on the radical here, that's an odd number. Or if you looked at it up here, this is an odd number. You don't have to worry about the plus or minus. And so I get y minus 2 is equal to 1 over the 5th root of 32 is 2, and that's squared. So y minus 2 is equal to 1/4. Add 2 to both sides, and I'm going to get y equals, what is that? 9 over 4. Okay. All right. So that's the answer we got, 9/4. But if you look at this, okay, if you look at this, we have to check our solution. And why in the world do we have to do that? Well, remember in the previous problems when we were solving those radicals, remember I said if you raise both sides to an even power, you have to check your solution, right? And you see when we did this, look what happened when we converted this to radical form. You can probably see it here. Remember, the denominator goes to the index. The numerator is that exponent there. So it's also like we squared both sides. You see that? We squared both sides. So we've got to check our solution. And so if we check it, I'm going to come right here and check. We've got to plug it back into the original. And actually what I'm going to do is I'm going to erase this over here and check it right here. So I've got to plug 9/4 into here. And so I get 9/4 minus 2 raised to the negative 5/2. And I want to know, does that equal 32? All right, so 9/4 minus 2, that is what? That is 1/4 to the negative 5/2. And I'll write the 32 down later when I get there. Okay. Is that right? Negative 5/2, 9/4 minus 8/4 is 1/4. Yep, that's right. All right. So remember, when you're evaluating this, if I take the reciprocal of the fraction, that changes the sign of the exponent. Remember, there's a property that a over b to the negative n is equal to b over a to the n. All right. And so now let's convert this. That's the square root of 4 to the 5th. Well, what's the square root of 4? Square root of 4 is 2, and then 2 to the 5th is 32, and that does equal this 32 over here. That checks, and so that's our solution. Okay. All right, so let's go. Let's look at this. Like I said, this right here is probably the longest and most, it's not really difficult, but it's just that it's so much material in this one section. Okay. All right. So this one, we've got an equation that is quadratic in form. So if you watch the videos, if you watch the college algebra video on factoring, college algebra -factoring, we factored a problem like this with U-substitution. But let me review it just real quick. So we know that x squared, let's say we got x squared plus 5x plus 6, okay, equals 0. This is a quadratic equation. If we take this middle term here, this x value, and we square it, we get the first term, don't we? Okay, if you square this, you get the first term. That's a quadratic equation. Well, if you look at this, if you square this, okay, if you square it, do you notice that you get this first term here? You see that? This is what we call quadratic in form. And the way that we do this is we use U-substitution. So basically what we're doing is we're checking to see if we square this middle term, do we end up with this first term? And yes, I realize you can see it without having to write it down, but let's just write it down. So I'm going to let U equal x squared minus x. I'm going to let it equal that middle term. Okay. Now you might be thinking, well, why U? Why did you use U? Well, I could have used anything. I could have used A. I could have used B or C. I mean, I don't want to use X because that's the variable of the original equation. But I can use any letter I want. It just typically when you're doing substitutions, a lot of times you use U. Okay. So I let U equal this middle term. So now I want to square both sides here. And when I do that, I get u squared equals x squared minus x squared. And you can see that when I squared both sides, I ended up with this first term. So what I'm going to do is I'm going to replace this first term with u squared minus 18, and I'm going to replace this middle term with u. All right. Now, doesn't that look a little better? That looks a little easier to solve, doesn't it? It looks like this one over here. And I can factor that. So that's going to be u, and that is going to be what? Minus 6 and minus 12. All right. And so I get u minus 6 equals 0, or u minus 12 equals 0. So u equals 6 or u equals 12. All right. So that's what we've got there. Now, we're not solving for u. We have to solve for x. X is our variable. We need to know what x is. Well, we've got u equals 6. Well, what is u? U is x squared minus x. So I'm going to replace this u with x squared minus x. And I'm going to do the same thing with this u. I'm going to replace it with x squared minus x. And now I got another quadratic equation to solve. Move the 6 over, factor. Move the 12 over, factor. So x squared minus x minus 6 equals 0, or x squared minus x minus 12 equals 0. All right. And then we factor. So we get x minus 3, x plus 2 equals 0. So x minus 3 equals 0, or x plus 2 equals 0. So x equal 3, or x equal negative 2. There's the answers there. And then this one, x minus 4 times x plus 3 equals 0. So x minus 4 equals 0, or x plus 3 equals 0. So x equal 4, or x equal negative 3. I know I'm going through the factoring and solving, just the quadratics, the basic quadratics. I'm going through those kind of quick, I'm assuming you know how to do that, okay? That section's before this one in the college algebra book, and plus we've done it quite a bit. So basically, what you've got here is you're making this the substitution of u. So what that's doing is that's giving us something easy to factor. And then once we solve it and get down to this, then we're going to take this and plug back in for u so we can solve for x. It's just kind of like a dummy variable to put in there to make this right here easier to factor. Okay? Because doesn't this right here looks a lot easier to factor than that. All right. All right, so let's look at the next one. All right, so here we've got another one. This right here, this one has rational exponents. So the first thing that might pop into your mind are the problems that we worked up here in example 3. But if you notice, we don't have just x raised to a power equals a number. We have x to a power minus x to a power. Okay, we just don't have a single term of x raised to an exponent. So this one, it's got 3 terms. So could this be quadratic in form like the previous problem? Well, this one is not as easy to see, is it? I mean, you can probably see it, but it's not as easy to see as the previous one. So I'm going to go ahead and do the U substitution. So let U equal x to the 1/3. Let it equal the middle term. And so U squared is x to the 1/3 squared. So U squared, and remember you multiply exponents, that's x to the 2/3. And you can see when I let U equal the middle term, I squared both sides and I ended up with the first term. So now let's replace x to the 2/3 with U squared and x to the 1/3 with U. And now doesn't that look much easier to factor? See, that's why we're making the substitution. It makes it easier to factor. And those of you that plan on majoring in math or going into engineering and stuff like that, get used to this kind of stuff, doing substitutions like that, because you're going to do a lot of it, especially when you get into calculus, rewriting things. All right. Or if you're taking some classes and you got some electives available to take and you decide you want to maybe take a calculus class as an elective or something, you'll see it there. So let's factor. So that's U minus 8, U minus 1. Okay. All right. So I get U minus 8 equals 0 or U minus 1 equals 0. So I get U equals 8 or U equals 1. All right. So now what did we do in the last one? Well, what does U equal? U equals x to the 1/3. So I'm going to replace the u's with x to the 1/3. So x to the 1/3 equals 8 or x to the 1/3 equals 1. Now remember, now this is like the previous example, right? We've got x to a rational exponent equals a number, x to the m over n. So for this, I'm going to do what? I'm going to cube both sides. 1/3 times 3 is 1. And so this is going to give me x is equal to 512. There's that answer. And then same thing here. I'm going to raise both sides to the 3rd power, or x equals 1 cubed is 1. Now, I raised both sides to the 3rd power. Let me ask you a question. Do I need to check my solutions? Think about it. Do I need to check my solutions? And if you said no, you would be correct, because I raised both sides to an odd number. So I don't need to check my solutions. All right, now let's look at these. This one is, it looks like quadratic in form, right? And it is, okay? Now, if you're taking notes, don't write this down just yet. So if I let U equal x squared, the middle term, then U squared is equal to x squared squared, and so U squared is x to the 4th. Okay? And you can see it makes the substitutions and everything. Now, when I get something like this, if I got an x to the 4th and then I've got an x squared like that, I don't do the U substitutions. I just do the U substitutions when it's, fractions like that, or if it's something like this, I've got polynomials in there. Okay. If it's x to the 4th and x squared, this is what I do. I know that's going to be x squared and x squared, right? X squared times x squared is x to the 4th. There you go. If you want to make the substitution, okay, if you feel better making the substitution, by all means do it. All right. So let's see. This is going to be minus 9 and minus 5. Is that right? Yeah. And so x squared minus 9 equals 0, or x squared minus 5 equals 0. Square root property, right? So x squared equals 9. X is equal to plus or minus 3. Here, x squared equals 5. X equal plus or minus square root of 5. And there's 4 solutions there. Okay, pause the video and see if you can work that one. Work it real quick and then hit play. All right, so same thing here. So I've got x squared, and let's see, what is that going to be? 32, that's going to be what? Plus 16 and minus 2. Okay. That one? Yeah. 6 plus 16 and minus 2, that works. So I get x squared plus 16 equals 0, or x squared minus 2 equals 0. Once again, look at that, square root property. So x squared equals negative 16. So x is equal to plus or minus 4i. There's 2 solutions. And then here, x squared equals 2. X equals plus or minus square root of 2. All right. So that's not too bad. Okay, so what about this one? I've got something in parentheses raised to a power, don't I? You see that? So what I'm going to have to do here is, well, let's get rid of that 1/4 power. How about that? Okay. So how in the world am I going to do that? Well, you guessed it. I'm going to raise both sides to the 4th power, right? 1/4 times 4, that gets rid of those parentheses there. And so that's going to give me 11x squared minus 18 equals x to the 4th. Okay. Well, this, you see this problem? That's just like these two up here. I just got to get everything on one side of the equal sign. So I'm going to subtract 11x squared and add 18 to both sides. And so that's x to the 4th minus 11x squared plus 18. And remember what I told you about the 0. It doesn't matter what side you put it on. All right, so now let's see. I hope this factors. I think it will. So let's see. We've got x squared minus 9 minus 2. And so x squared equals, getting ahead of myself, x minus 9 equals 0, or x squared minus 2 equals 0. So x squared equals 9, x equals plus or minus 3, or, and then I've got x squared equals 2, x is equal to plus or minus square root of 2. All right. Now, are we done? That's the big question. And the answer is no. And why are we not done? Because we raised both sides to an even power. So I've got to take the original equation, right? And I've got to check my solutions. So the solutions that I have to check are 3, -3, 2, and negative square root of 2. Okay? Now, right off the bat, I can cancel those out. I don't even have to check them. Because I'm taking, if you take the square root of the 4th root or the 6th root of something, that's going to always be positive. Remember, whenever you take the square root of a number, it's positive. Whenever you take the 4th root of a number, it's positive. So if this side over here is always positive, then there's no way it's going to equal a negative number. See, I would have to plug the -3 into both of them right there. You see that? And so this would never equal -3. This side would never equal negative square root of 2. All right? And so I would have to check the x equal 3, and I would have to check x equal, that's square root, x equal square root of 2. All right? And look, I'm not going to go through and do all that to save time. The video is already long enough. So, but like I said, make sure you check it. Plug them back in. Make sure you get the same thing on both sides. All right. All right, so let's look at this one. All right, so how about this problem? Well, we've got the absolute value of x squared minus 2x minus 16 equals 8. And the first thing that might pop into your head, what you might be thinking is, oh gosh, I don't know how to work that. But actually you do, okay? Because there's a section in college algebra right before this where you solved absolute value equations. Okay, remember that, where you had to rewrite it? Okay, so if you have the absolute value of something equals a number, then what's inside the absolute value equals that number, or what's inside the absolute value equals the negative of that number. All right, so let me show you the easiest way to do it. If you have this, you have to rewrite it into this in order to solve it. If you don't know this, you can't work absolute value equations. So basically all you're doing is, look, write the problem down twice. That's all you got to do. Write the problem down twice, and then this number is going to have a negative. See, that's all I'm doing. I'm writing this without the absolute value. I know I didn't say that earlier. Write it twice without the absolute value. We're writing this twice without the absolute value, and you see the last k, it gets a negative on it, and that's all it is. Now look at this. We've got two quadratic equations to solve. So let's subtract 8 to both sides. So I get x squared minus 2x minus 24 equals 0. And so let's factor. So that's x minus 6, x plus 4. Yep. So x minus 6 equals 0, or x plus 4 equals 0. So x equals 6, or x equal negative 4. There's two of the solutions. Now this one, let's add 8 to both sides. I don't know why I put a 1, but add 8 to both sides. So x squared minus 2x minus 8 equals 0. And then this factors, so that's x minus 4 times x plus 2. So x minus 4 equals 0, or x plus 2 equals 0. And so x equal 4, or x equal negative 2. And there's your solution. All right. We've got 2 more problems to work, and that's it. Okay, don't leave now if you've come this far. Okay. All right, so let's look at this. We got absolute value of something equals the 5x. Okay. All right. Now, let's go ahead and write it. So x squared minus 6 equals 5x, or x squared minus 6 equals 5x, and put the negative. Okay? All right. So once again, quadratic equation to solve. All right? Get everything to one side, set it equal to 0. So I'm going to subtract 5x to both sides. So I get x squared minus 5x minus 6 equals 0. And then let's go ahead and solve this thing. So x minus 6, x plus 1. And so x minus 6 equals 0, or x plus 1 equals 0. So I get x equals 6, or x equal negative 1. All right, so now let's add 5x to both sides. So I get x squared plus 5x minus 6 equals 0. So let's see. So I get x, what is that going to be? Plus 6, x minus 1. So I get x plus 6 equals 0, or x minus 1 equals 0. So x equal negative 6, or x equal 1. All right. And so that one's going to get crossed out. That one's going to get crossed out. Pause the video, think about it, see if you can figure out why it's getting crossed out. All right, so let's talk about why those are crossed out. So if you look over here on the left-hand side, I've got the absolute value of something, right? It makes no difference what's inside that absolute value. This left-hand side will always be positive, right? So what happens if I plug a negative 1 in? What do I get on the right-hand side? Negative 5. There's no way the left-hand side can equal negative 5. And then the same thing for the negative 6. That would give me negative 30. There's no way the left-hand side can equal negative 30. So those get crossed out. And so now that's my two solutions, 6 and 1. All right. All right. Last one. All right. Just think, you get finished watching this problem getting work, you can stop the video and go relax. Do what you want to then. All right. So on this one, I got absolute values on both sides. Okay. So the easy way, just look at this. Write it down twice. Leave a little extra space right there. Okay, write it down twice. And on this one, put it in parentheses. Put it in parentheses with a negative in front. Okay, that's all you got to do. You've got to let this equal this, or this equal the negative of this. And that's all it is. And yeah, let me say this. If you wanted to, when you write it down the second time without the absolute value, if you wanted to, you could put the negative in front of the first one. Doesn't matter. You just got to put it in front of one of them. Okay? Let's put that negative back. And then we just solve. So let's see, subtract x, add 3. And so that's going to give me x equals 3. There's one solution, right? Let's see. And that is not 3. That is 2. 3 minus 1 is 2. Okay. See, this is too much for me too. I've been working too many problems. I'm starting to lose my mind now. All right. So now to solve this one, let's distribute the negative. So x minus 1 equals negative 2x plus 3. And so then I can add 2x to both sides, add 1 to both sides. And so I get 3x equal 4. Divide both sides by 3. X equal 4/3. And we are done. So I hope all that made sense. I know it's a ton of stuff. It's a lot. Okay. But you know, it is what it is. Hopefully you took notes throughout the video, and you know, just go refer back to your notes and try to work on your homework like that. So hopefully it helped. Check out my other videos. Give me a like, share, and subscribe, and thanks for watching.